I'm going to let the chatter die down. I hope you guys have forged some new friendships and new relationships, and so far the conference has gone really well for you. For those of you who filtered in a little bit later and didn't see my intro, my name is Travis Vander. I work for a company called Stride Consulting. They're based here in New York City, but I work remotely from Denver because you can see the sky there. This morning, I'm going to talk to you about Phoenix channels and their vast potential for both good and evil. So what do I mean by that? Well, channels are the killer feature of the Phoenix framework. They make development of real-time features a complete snap. And so that's great. Their potential for good is boundless. However, Phoenix channels are still new. And because Phoenix channels are still new, this means that we as a community don't yet know how we're going to abuse these things over and over and over again all over the world for the next decade. Okay, so how did I come up with such a view of Phoenix channels as this kind of balance, this yin and yang of potential good and potential evil? Well, when I first started playing around with these things, they felt familiar to me. And they felt familiar to me because of their similarities to controllers, and specifically Rails controllers, in both structure and responsibility. Which brings us to the title of this talk, Channels as Controllers. Channels are very similar to controllers, but they're not controllers. So it's a little bit misleading, and we'll go into that a little bit more as the talk goes on. First, some similarities. Like a controller, a Phoenix channel defines a set of handlers for pattern-matched messages, where a controller is going to handle things that have been pattern-matched by your router. A channel is actually going to pattern match messages that come across the wire, come across a WebSocket connection. Like a controller, a channel's handlers often have side effects. For example, they could persist a record to the database, they could result in the firing off of an email, trigger some sort of background job, etc. Also, like a controller, channels allow you to grab params from the message that you're handling, in the same way that a controller allows you to grab parameters from an incoming HTTP request. So just looking at these things, they feel very similar to controllers. So in short, working with them was familiar, which made me feel immediately competent, which is rare. It felt really great to just be like, oh, this makes sense, and I can develop, like, take part in the retrospective app, because really that's a glorified chat app, right? Which none of us ever thought we would build, myself included. But then some time passed, and of course, the responsibilities of our channel grew, and they grew to ill repute. Not long ago, while examining these responsibilities, we realized that our implementation was mixing concerns. And that felt familiar too, but in a very, very bad way. How many of you are coming from Ruby, have a Ruby background? Okay, so pretty much everyone. We're all like kind of migrating. Not all of us. Ruby's still great, and yeah, but there's a mass migration kind of that has happened and will continue to happen. Of you, how many of you have ever seen a controller that was 500 lines of code or more? Cool, so all of you. Great. And of you, how many of you have seen one, a monolithic controller that was 1,000 lines or more? All right, now look around. Keep your hands up. Look around. Okay, so not only is this a thing we see out in the wild, it's a thing that is not uncommon. And what's really sad about this is that at one point, those 1,000-line monolithic controllers that you saw were probably small and relatively focused as far as their responsibilities. But then something happened, and that something is called a deadline. So a deadline happened, and because the code had to go somewhere, they just kept packing responsibilities into a controller, some nameless dev. It might have been you, it might have been me. And of course, other developers came along, saw the pattern that had been established in the code base, and continued to do it. And not only in that code base in other controllers, but also in other code bases in other companies all across the world. So this inertia, this idea, this like thing that we were okay with spread all across the world, and now we've been dealing with it forever. And there's a lot of cognitive overhead when you are trying to work with a class that is doing 50 different things. Even if you think, oh no, it's just a line count, I'll use C tags, or like I'll find a way to navigate this beast. There's still cognitive overhead that you're not even aware of when you're thinking about all the things that are happening in the file or the class that you're working with in Ruby. Cool. I don't want that same thing to happen to channels, and neither should you. Because most of the people in this room are professional programmers. And as professional programmers, you know that the patterns that your community adopts, what was I going to say? I had a smart saying, so I want to make sure I don't bork it. That the patterns that your community adopts are going to live forever, even if those patterns are anti-patterns. Cool. Thankfully, that doesn't have to happen because channels are still new, and we as a community have a chance to kind of dig into, develop, and share extensible patterns for working with channels. And along the way, we should also share the anti-patterns that we come up with or that we discover, because those can often be just as informative. Which brings us to this talk's subtitle, which is an exercise in refactoring, and this is way too small, so let me make that bigger for you. Boom, boom, boom. Great. If that happens again with the code, somebody please let me know, because we are going to be running through some code, and I want to make sure everyone, especially in the back, can see it. Okay. So we recently refactored the Phoenix channel that was referenced earlier, this one that was packing in a bunch of responsibilities. And in doing so, we learned a lot about them. My high-level goal for this talk is that by the end of the refactor I take you through today, you have a newfound respect for channels and an awareness of what responsibilities they're actually suited for. So you can keep these things slender as they as your applications grow. But before we get to that refactor, let's take a quick look at some learning objectives so that you know exactly what I'm hoping you come away with today. Great. So following this talk, you should be able to reduce unnecessary duplication, both server-side and client-side, by returning a 3-element tuple that nobody knows about from the join callback on the Phoenix channel module. You should be able to use Phoenix endpoint.broadcast, or the broadcast function, to extract responsibilities from a Phoenix channel out into other modules, because that's another thing that I don't think people are using quite enough. Additionally, you should be able to identify opportunities for using macros to remove boilerplate in your channel's message handlers, because you're going to see a lot of the same stuff over and over and over again. And 4, you should be able to articulate in technical terms what Phoenix channels are amazing at. Great. Awesome. Let's do a quick audit of the responsibilities that have accumulated in the channel I referenced earlier. So here we have our retro channel implementation. I'm going to make this comically large. Can the folks in the back see that? You good? Awesome. Great. So let me bring my cursor up. What side of the screen are you on? There you are. Okay. So in lines 6 through 11, this is some boilerplate you are going to have to add for clients to actually be able to subscribe to your channel's topic. This is something we probably can't really get rid of if we want folks to join our channel, which we do, or subscribe to the channel's topic, rather. Cool. On line 14, you see that we are tracking those who are currently present or who the other subscribers to this topic are at any given moment. In lines 16 through 17, and we'll be revisiting this, so I'm going to keep this kind of quick. In lines 16 through 17, we are retrieving some persisted records from the database, picking out the retro itself, eager loading the associated ideas, and then here we're actually pushing the initial retro state down to our clients. Okay, and moving on, these guys are all kind of bundled together. So in this case, we just have some handlers that really do the same thing in every case. They are handling a pattern-matched message and payload, and then just turning around and broadcasting it to anyone else who happens to be subscribed to this topic. We do the same thing for enable edit state, disable edit state, user typing idea, and idea live edit, which I'm realizing now should have followed a better naming convention. Great. Okay, so already we've got some boilerplate. We've got some a push of some initial state down to our clients. We've got presence tracking, and we've got a bunch of just like message dishing. This is where it gets kind of ugly and where our spidey senses probably should have gone off. I'm going to make this a little bit smaller here, but here in this new idea handler, we are inserting a record. We're inserting an idea into the database, and then we're turning around and letting everyone know, hey, a new idea has been received. And just below that, we have a handler for idea edited. And idea edited updates a record and broadcasts, letting everyone know, hey, this thing got edited. Down below, same deal. We handle in the deletion of an idea, we remove it from the database, and we let everyone know which idea has been deleted so they can update the UI, or the front end can update the UI appropriately. Great, so that's a little weird. Considering all the other responsibilities that we've already seen, we're now tacking this guy on. Okay, and now proceeding to the next stage. There's two handlers here, and they both do roughly the same thing. They handle the proceed to next stage event. The one difference here is that when the stage you're proceeding to is action item distribution, you also have an additional side effect here of sending out an email of all the action items, so people get some actual value out of the retrospective going forward. Cool. And in both of these, you'll see we're actually updating the underlying retro record. And the reason we need to do this is because if you're not subscribed to a channel, when a message goes out, you just don't get it. So if somebody joins a retrospective after it's already progressed to the action item stage, they're not going to see that UI, which is why we have to pass them that initial state right when they join the channel. And that update retro, this is actually a private function, but I want you to trust me that we are in fact updating this in the database. Okay. Now the last responsibility is we're doing some custom presence work here. I don't know how many of you know about the Phoenix Presence API, but it's really fun. It's really great, and you should all play with it. But here we're doing something a little bit custom. We have a business rule that if the facilitator leaves the room, we want to ensure that that role goes to the next longest tenured user. So we're intercepting presence diff events, which the presence module just kind of sends out under the hood, and we are just sending out a whole new presence state. Okay, so those are three more fairly big responsibilities that we're seeing here. It's not idea CRUD, but it's idea CUD. We're creating, updating, and deleting. And we're updating retros, sending emails, and now dealing with some custom presence logic. So if we aggregate those concerns, come on, buddy. It's a lot of responsibilities. And here's where I think these patterns, these monolithic controllers, originated. Responsibilities find their way in, and you find a way to refactor what's going on in those controllers out into classes, or in the case of Phoenix, modules. And we only have about 95 lines of code here, so it doesn't feel like it's going to screw us over going forward. But we've already accumulated a bunch of responsibilities, which is a much smellier smell. So over the course of the next 20 minutes, we're just going to kind of go through how we refactored this and how we extracted some of these responsibilities from our retro channel implementation. Okay, let's do this. First, we're going to go through the technical nuts and bolts sense, because many of you have probably refactoring in the nuts and bolts sense, because many of you have probably never worked with Phoenix channels and just need to get familiar with the syntax. And later on, we'll actually talk a little bit about application design and service-oriented architecture. And beyond that, we'll use some macros just to slenderize our channel a little bit further, because macros are fun when they're used responsibly. Real quick, the first responsibility that we are going to kill here is pushing some initial state to the client. And I'm going to start by showing you the documentation for this join 3 callback you see in the hex docs. So if I can scroll in. Oh yeah, that's really nice. Okay. So here, the viable return values you see are a 2-element tuple where it's OK in the socket, 3-element tuple with OK a map in a socket, or just an error with a map describing the error. Now, in the official channels guides, what you see used, and which you therefore probably end up using yourself, is this 2-element tuple. You see it in the guides, you see it in the chat example that Chris McCord put up on GitHub. And that's sad because people don't use this 3-element tuple because they tend not to know about it. What this second element is it allows you to pass some initial state on the actual join to your client. So let's take a look at the custom push we had to do so that our client would get the initial state, and see if we can actually leverage this 3-element tuple. There you are. And way up here. So here we're doing a push of the retro state with this data we've retrieved from the database, and we actually want to return that in the join. And this has 2 benefits. One is here, server side, and the other is client side. So we have a top-level React component that speaks to our retro channel, and you see here in these lines we have a custom handler for this event. And we already have a callback, a handler, for when we successfully join a channel. And that's where this payload is going to come in once we return it from that join 3 callback. Oops. So here, rather than push a custom event, we can bring the retro up, and right here, return the map. And what this allows client side is for us to trash this. Whoops. First, I'm going to rip off the callback because we do need to set the state when we successfully join the channel. So, sorry, the mouse is a little bit laggy. So here, and we'll one-line this for parity with the receive error callback. And now we can trash this client side. Okay, so that's one responsibility we've been able to effectively kind of remove from this, because Phoenix wants you to do this out of the box. Now, this seems like somewhat of a trivial refactor, but I want you to imagine a world if we go back in time here. Whoops. What if you were doing something like yada? What if you had more complex initial state you were trying to get down, but you couldn't do it all in one convenient bundle? I'm sorry, not if you could do it all in one convenient bundle, but if you were sending multiple events down. What this would necessitate so that your client-side application could bootstrap would be writing JavaScript handlers for each one of these events. And you wouldn't want to do that. We didn't run into this in our code base, but what I would recommend is not pushing custom events and really just encapsulating the construction of your kind of complex initial state structure into a module. Something like initial retro state build, passing in just the retro ID. So you can keep your channel kind of clean. You don't have to do this construction here. Put that in a module, just a very common refactor. Great. Okay. So moving on. Now that you know how to get your channel off on the right foot, let's now tackle the elephant in the room. And maybe you guys don't know what this is. Maybe it isn't an elephant in the room in that case. But the creations, updates, and deletions of the idea model. It's not, Phoenix handles these things pretty well already. Where do we conventionally house in Phoenix and in Rails actually do cruddy stuff? And you can shout it out, we're all family here. What? Potentially. Handlers specifically. Where do we house the handlers? Controller, yeah, RESTful controllers. Phoenix already does CRUD stuff very, very well, and with very, very minimal setup. So what are we going to have to do to extract the cruddy functionality from this retro channel out into a controller? We're going to need three things. Oops. First, we're going to need a controller with REST actions. Two, we're going to need a means of broadcasting from the controller to our channel subscribers. Because if you remember from the retro channel, it not only updates the database, it also then broadcasts that change out to everyone who's subscribed. So we'll need a means of broadcasting from the controller to our subscribers. And three, we'll need a JavaScript REST client. The REST client is pretty basic, as is the controller. The one thing we had to do here that was a little bit interesting is that because you're not authenticating in the same way you would via channel, you have to make sure you pass a cross-site request forgery token down to your client. So the REST client can include that in the header. But this is actually a fairly trivial refactor because Phoenix provides you with this guy. You can generate a JSON controller in about one line with test very, very simply. All we had to do here was actually just delete the creation code because we don't create, we had to delete one of the actions that we don't use, the read, the index action. But we get this controller for free with tests, so that itself is trivial. Writing the JavaScript client was also somewhat trivial because it's just following RESTful conventions. Okay, which brings us to your app endpoint broadcast. This is something I never tell programmers to memorize something, but you should memorize this because this can allow you to create a more service-oriented architecture in your Phoenix code bases. So I'm not going to take you through the controller or the REST client code because that's all boilerplate that I'm guessing most of you have seen before, having worked a lot of you from in Rails. But I am excited to show you the end result of extracting our cruddy operations out of our channel and into controllers using this endpoint broadcast function. So let's do a little bit of that. Bring this up, and I'm going to have to make this quite a bit larger. Get checkout B. Okay, can y'all in the back see this? Is that pretty big? Cool. All right, so let's check out diff 1. This is an isolated diff of what we had to do in the controllers just to transfer the broadcasting responsibility from the, well, not really from the channel, but allowing our controller to actually broadcast to our channel subscribers. We wanted to get this in place before we actually shift the responsibility from the channel to the controller. So here we are in the, where's my cursor? There you are. Here we are in the idea controller, and we give ourselves an alias of the endpoint up here, and provided you can successfully insert an idea, now all you have to do is broadcast to the appropriate topic, the event that we were broadcasting in the channel, along with the payload. One thing you'll notice is missing here is no mention of a WebSocket. You don't need to have the socket to be able to broadcast to a channel subscribers. And that's great. And we're going to do something almost identical down in the update and delete actions. Just ensuring that we use the appropriate event name and payload. Oh, cool. All right, so let's see what just allowing our controllers to do there allows us to do with our channel. So this is the isolated diff in the subsequent commit where we actually stopped handling these messages in our channel and started using our JavaScript REST client to talk to these controllers. We're able to delete the creation, updating, and deletion from this channel. And it's pretty simple. We follow almost the exact same pattern when dealing with the, when dealing with the retro controller, because we were updating before in our channel. We were changing the stage of the retrospective as well as sending out some emails. So this diff is even smaller. If the stage happens to be the action item distribution, make sure you send out the email. And here we encapsulated the actual broadcast and render because we're doing the same thing in both cases here in a private function where we are broadcasting the event name with the appropriate payload and rendering the show view. And what this allows, again, is for us to delete some code, but more importantly, delete some responsibilities from our channel. So now we don't have to worry about emails. We can cross that one off the list. We don't have to worry about updating the retro. That responsibility is no longer housed in our channel. So this is incredibly powerful when it comes to application and service design because it allows your channel to focus on what it's amazing at. And one of the learning objectives from this talk is for you to be able to articulate what channels are actually amazing at. That's a terminal. Why is that not going? So what are channels amazing at? They're amazing at providing a means of subscribing to a topic. And after that, they're really amazing at passing messages among those subscribers. The top one is the most important because the moment that this channel has subscribed you to a topic, you don't have to handle anything else in there if you want to broadcast anyone in that topic. It allows you it sits on top of Phoenix Pub Sub, just make sure that you're properly registered as somebody who is interested in this topic. And then you can broadcast from anywhere. It doesn't need to be a controller necessary, but from any module where you can reach your application's endpoint module. Okay. So what if we revisit our concerns? We've been able to cross off quite a few of them. We've been able to encapsulate the initial state just in join 3 as was intended. We no longer create, update, or destroy ideas in our channel, and we no longer update retros or send emails from our channel. But they are still doing some unique presence work and passing messages. This is great. We feel pretty good about this, but we're not done refactoring yet. I promised you that we would look for opportunities to use macros to slenderize our channel because macros are fun when used responsibly. Anecdote, a few years ago, when I was a younger man, I wrote a bunch of metaprogramming in Ruby, and it was in a test suite because I was pretty clever. I told somebody to hold my beer, and I thought I was going to make everyone's life better by writing a bunch of sweet, dynamically defined methods. Months later, I forgot that this existed, and I came across this code while maintaining the test suite. And I said, Jesus, who did this? And of course, I get blamed, and it was me, which hurt. It hurt my ego. And I'm not I don't have any sort of condition. I'm not a drinker, so there's no reason I should have forgotten that this was me because it was a real mess. So I made a promise to myself that day that I would no longer do any sort of metaprogramming if I couldn't justify putting it in a library. So of course I wrote a little library to slenderize the remainder of our channel, which is down here. So did I check out the appropriate? Where are you? Okay, yeah. So you see a bunch of similarities between these 4 handlers. Really what you're doing is taking in a message and a data structure, pattern matching on the payload that comes through, turning around, broadcasting the same message in the same payload. We can use macros here to slenderize this significantly, and it won't take much. So here, all we need to do, and this module is called Slender Channel, but you could implement this yourself very, very easily if you wanted to. This macro, handle in and broadcast, basically unquotes the event name and the event payload, the actual structure that you need to match, turns around and broadcasts the same unquoted event and broadcast. For those of you who haven't done any or seen any metaprogramming in Elixir, big difference between Ruby is that it's happening at compile time. So if we want to make sure the appropriate handlers actually get defined, we need to unquote these things as values. And once we have this in our pocket, it makes refactoring this thing and slenderizing our channel very, very simple, and I feel very, very rewarding. So all we'd have to do is use Slender Channel. And then in all these cases, where's my Diff? Oops. Boom, 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 boom. Boom, boom. And then this is the rewarding part. Boom. Cool. So we've gotten rid of a bunch of responsibilities and we've been able to slenderize. Let's make sure. Did I bork this? Yeah, I did. I got to say handle in and broadcast. Let's make sure I didn't handle in and breakfast. That'd be good. So let's run the test and make sure this actually still works. That's not a failed test, that's a diff. Don't get it twisted. Cool, so it still works. Great, so we've been able to really trim up our channel implementation here. And it's not perfect, we're still doing some custom present stuff, and we haven't played around with that enough to know if it should be housed here. This is kind of what it looks like in the examples you see online. But we're still so early in this ecosystem that we don't know if the examples we're seeing online are going to end up giving our teams a limp 5 years from now. So I hope, if anything, you guys are very mindful, you guys and gals are very mindful using channels going forward. Because the patterns that we start using today are going to have inertia, and they're going to spread like wildfire as people see them in code bases here and elsewhere. And with that, I guess, do we do a Q&A? 5 minutes? Yeah, so if anyone has any questions, happy to answer maybe any syntactical stuff if you've never seen channels. Yeah, in the back.
Generate the topic in the controller would be extracted broadcast. Do you have any strategies for managing and generating those topics in different call sites? If it's all in the controller, at least you see.
That's a great point.
You see them all together, but when you start to break that apart, how do you manage that? Obviously, this is a simple as it scales.
So I'm going to try to rephrase that, and please tell me if I'm wrong. So as your application grows, how do you manage the number of topics?
You're generating the topic here, like a joint retro with retro ID.
Okay.
You're generating that same thing in the controller when you extract the broadcast.
Yes.
Is there a way to make those call sites more obvious than certain tests?
Off the top of my head, I'm wondering if you could just consolidate these things and really extend the broadcast pattern, because what you could do is consolidate, have one channel just manage a collection of other topics. Like the channel itself would have a topic, but then it could broadcast to a bunch of child topics so that that would only live in one place. Does that make sense?
Yeah.
Cool.
In the front?
What's the difference between broadcasting and like gent messages? Gent server messages, sorry.
Yeah, so what is the difference between gen server messages and broadcasting? Underneath the hood, I don't want to talk out of my ass, I don't know. No, I don't know.
It seems like it's a gen server message with some extra convenience.
Yeah, like you see when, like where you would have init callbacks and all sorts of things in a gen server, I think a lot of those things are masked from you with the channel because you're using join, but you see a lot of the same conventional responses of these tuples that need to be returned from your channel. So I don't know exactly how that works. I know that that channels sit on top of Phoenix PubSub, so that's managing the actual message sending across processes. Anyone else? You there with the beard.
There could be so many people in this room. Forgive me if you mentioned it, but what's the name of this project, of the retro project?
Oh, I really screwed that up before. So, no, I did. Let's go to, so this, we're calling it Remote Retro because we're not original. But here, what I wanted to show everyone is that, yeah, it's open source, but you need to know where to find the code. So this is housed at Stride NYC's account, Remote Retro. And so right now, before Phoenix projects, or sorry, GitHub projects came out, we were using ZenHub, which is a really great Chrome extension that kind of turns your GitHub repos into a sort of Kanban-y board. So here, if I'm really bad at this cursor stuff. Where am I? There you are. Boom, boom. So you can see the boards. I'd like to think we have a developer-friendly backlog of stories, bugs. Obviously, this one drives me nuts. But yeah, stride-NYC is the GitHub org, and the project is remote_retro. We've got a team of people who try to be as responsive as possible when it comes to answering questions. I think what we're going to have to do now, like right now we have a Slack channel at Stride, but what we might have to do is open that up, open a channel on the actual Elixir Slack. Man, that light is rough. Way back in the corner, in the back corner. Yeah, you.
Less of a question, I guess more of a comment. It's going to sound loaded, but it's totally not. I wonder if you thought at all that the pattern that you basically just put out, separating your concerns between the channels and the controllers, really very similar in my mind to action cable in Rails 5.
So I can't speak to that. I don't think that's a loaded question. Maybe it is. I haven't worked with action cable in Rails 5. Okay, so the pattern that I just proposed of extracting things out into controllers is perhaps very similar to action cable in Rails 5. Did I get that? Okay. I would actually open that up to the floor because, again, I can't speak to that. Is it? Did I just regurgitate a bunch of Rails 5 stuff? Let's say no in the interest of time, I guess. But yeah, I'm just a big old copycat. Yeah, I think I've run out of time here, but I thank you for listening to me. Thanks.